For part A of this question, we want to determine the derivative of y equals 2x sine of x with respect to x. So to do that, we need to recognise that this is two functions multiplied together. Therefore, we need to use the product rule for differentiation. So to apply the product rule, we'll do a little bit of working out to the side where we let u be the first function, which is going to be 2x, and v is the second function, and in this case it is sine of x. And then we need to calculate the derivative du dx, which is simply equal to 2, and the derivative dv dx, which is going to equal cosine of x. Now from the formula sheet, we know that the derivative d dx of a function u multiplied by v is simply equal to u times dv dx plus v times du dx. So therefore the derivative that we're after, which can be represented as dy dx, is going to equal u, which is 2x, times dv dx, which is cos of x, and then we add on to that v, which is sine of x, multiplied by du dx, which is simply 2. And now this can be neatened up a little bit to become 2x cos of x plus 2 sine of x. And now for part B of this question, we're asked to hence determine the antiderivative of x cosine of x. So to start off this question, we're going to write a statement. And this statement is going to help organise our thoughts for this question. So because of this word hence, it's inviting us to use information from the previous part of the question. So that's what I'm going to use to create this statement. And the statement will be that the derivative d dx of 2x sine of x, so that is going to equal 2x cos of x plus 2 sine of x. So that is an equivalent statement that we found from part A. And now what we're going to do is, if this is equal, we can integrate both sides and it will still be a true statement. So we're going to integrate both of these sides with respect to x. And we know the integral and the derivative are opposite operations, so they'll undo each other. So on the left-hand side, we'll just be left with 2x sine of x is equal to, and on the right-hand side, we're going to have 2 times the integral of x cosine of x, which is what we are asked to find, and that's going to be the derivative with respect to x. And because that 2 is simply a constant, we can take it out the front of that integral symbol, and then we'll still have 2 lots of the integral of sine of x dx. Now just to keep track of what we're doing between this step and the next step, we're going to simplify this down by evaluating the integral of sine of x, and we're also going to divide by 2, because there's a 2 here that doesn't appear in front of the antiderivative that we want to calculate, so we need to get rid of that. So therefore, in our next line, 2x sine of x, if we divide that by 2, is just x times sine of x, and we know that that is equal to, and dividing by 2 has gotten rid of that 2, so that's just the integral of x cos of x, which is again what we're asked to find in this question. And then this 2 that's multiplying the integral of sine of x will be gone because we've divided by 2, and we know the integral of sine of x is negative cos of x. And now because we've performed our integration, we need to add plus c, which is the constant of integration, which takes into account any vertical translations that are lost during differentiation. So that plus c needs to be in there now. And now the last part of this question is just to get the integral of x cosine of x by itself. So therefore, the integral of x cosine of x with respect to x is equal to x sine of x. And then this negative cos of x we need to add over to the other side, so it'll be plus cos of x. And then we also move this c over, and because c is a constant, we can just write plus c there. If you wanted to be thorough, this could be constant 1 and this could be constant 2, because obviously you've subtracted it to get it over the other side, so it is technically a different number. So try not to be too freaked out by that c1 and c2. It's just to say that they're not actually quite the same constant. You could have just had negative c there if you wanted. So that there is the answer to part B of this question, which was to find the antiderivative of x cos of x.